Hello. Today I'm going to demonstrate how you can do the homework 7, which is the last homework, and maybe this is the last lecture. So there is next week there is one more class on next Tuesday, but I think we don't have enough time to start a new chapter. So I'm considering just doing some review of the materials so that you can prepare for the final exam. And I also remember that there are 3 homeworks due next week. Next week I mean May 11th, 12th, and 13th. So the reason why the 3 due dates are close to each other is because, as I mentioned in an announcement, the university calendar is, I don't know who makes the calendar, but as you see, the last class is on 11th, but the graduation ceremony is starting on 15th. So I do not have any time to grade yours. The grading deadline is pretty tight, so nearly physically impossible to do anything else. So we have no choice but do everything as soon as possible, and I will really hurry to grade your exams, and so that if you fail this class, you will not be able to graduate. So to prevent that kind of problem, I'm going to notify if you fail. So I hope not, but I will be fair. I do not consider whether you graduate or not is not taken into account in grading. So what I can do is just grade as early as possible, so that you can prepare for alternatives if possible. Okay, so this video will be posted on May 5th, I guess, Wednesday. But the due date of this homework is a week from this video is posted. So there is no time to lose. Please do it as soon as possible. Okay, so let me start. So this homework is about the probit and logit model. Both of those models are used when the dependent variable, the outcome, is binary. Whether it is the outcome only uses 1 and 0. There are only 2 outcomes, 0 and 1. In our example, let me open the data first. Here is our data, and this is a very interesting data. So in 2008 and 2009, there was a huge financial crisis, subprime mortgage crisis, and so many of you may remember what happened. A lot of people lost their jobs, and there was a very turbulent economy at that time, and now it is fully recovered, and we are hit by another crisis last year. But anyhow, looking back at the previous one would be interesting. So the sample from the data is those who are employed full-time before the crisis in 2008. So and those employed workers are interviewed again after the crisis, and they are asked if they are still employed or not. Some of them may have lost their job because of the crisis, but others may be still employed. So we can tell who are vulnerable to the financial crisis, what kind of socio-economic groups are vulnerable to in their job security. And you may use a lot of variables. There are a lot of variables. Say employed is the main outcome. Whether they are still employed after the crisis or not. If it is 1, employed, 0, not. So this is our outcome. And you may use age, race, like marital status, union earnings, and like where they live, and whether their employment was by the government or in a private sector, and also education and female. There are a lot of variables. Of course, all of them are important, but just to make the model simple, we are going to use employed as the dependent variable, and age and female. So only using the demographic variables, we will see who are vulnerable to crisis. So like for simplicity, I'm going to delete all the other variables simply by using keep. You only keep those variables, and all the other variables are deleted. So let me do this. So we only have now 3 variables, and the other variables are gone. So the first thing I recommend you to do here is simply just have a look at the data. There are 5,412 observations, and their average age is 42 years old, and standard deviation minimum is 18, maximum is 63. Okay, and the employed variable is a dummy variable, which can be told, you can tell from this. Minimum is 0 and maximum is 1. So it is always 0 and 0, 1, 0 and 1, 0 or 1. And the mean is 87.5%. So remember, for a binary variable, the mean must be interpreted as the probability of 1. 1 means employed, so this means 87% of workers in the sample are employed. And similarly, female is 48.8%, so about 49%, and 49% of the sample are women, and also the mean is interpreted as a probability. So this will answer the first question in the homework. Alternatively, you may use this command, mean employed variable. This calculates mean as this estimates the mean, but it automatically calculated here. So same thing. Just in case if you want to calculate the confidence interval for the mean, then you may use this command. I'm showing you more commands because this is the last class. So it will be useful just to see those commands. And okay, that's it. And first analysis is regressing employed on age and female. And I will use robust option. If you use the robust standard error, you will get this result. And from here, it looks like, so now this is linear regression. The command is the same as what we have done in earlier chapters, but the interpretation is now different because the outcome variable is binary. Therefore, the linear regression model must be interpreted as a linear probability model. So everything must be interpreted as the probability. For example, the intercept is the expected value of the outcome when age equals to 0 and female equals to 0. But now you have to interpret this as the probability of being employed. So probability of employment if age is 0 and female is 0. So if all the covariates are 0, the probability of employment is 83%. Of course, it means nothing because age cannot be 0, but just technically, mathematically, the interpretation must be probability. The point is, it should be interpreted as a probability. And furthermore, if you are female, female is also binary. So the coefficient of female is minus 0.02. So this means if you are women, the probability of employment is 2% point lower than the male counterpart. So female is more vulnerable by 2% point. And how about age? If you are 1 year older, then the probability of employment increases 0.1%. 0.1% point. So the older you are, the more likely to keep your job. Interesting. So I thought when firms fire people, I thought they would fire those who are paid highly, but my expectation was wrong. So like younger workers are fired more, more fired according to the regression model. And the t statistic is 2.6 and minus 2.3. Both are outside of plus minus 1.96. Therefore, the p-value is 0.9%, 2.2%. So age is very significant at 1%, and female is significant at 5%. So both are significant, but if you compare them, age is more significant. This is what we do in the linear regression model. So here, you may just use those numbers to calculate the probability of employment for 30 years old and 40 years old and like 50 years old. That is always possible, but I will give you a trick because later linear regression model is simply enough to calculate the predicted value. But in the probit or logit models, the prediction would be more complete. It is more difficult to do it by hand. So I will just give you a simple trick. So here, I will first show you, let's do it this way. So if you click statistics and post estimation, click post estimation command, and there is a option predictions, and the first one, predictions, simply we are going to do predictions, and this predicts the outcome based on the covariates. Say I will define the new variable name as probability, and here we are using linear predictions. You may do something else, but we are only using this. And okay, and then it does not show any difference. So this is typed. This is what we just did, and it does not show what happens right now. But as you see, there is a new variable defined here. Prob is the variable name that I used, and if you open data editor, it has another variable. This contains the predicted outcome based on these covariates, based on these regressors. So for example, the first observation is a 53 years old man, and his probability of employment after the crisis is 89.7%. And the second observation is a 39 years old woman. She has a probability of 86%. So in this way, like for example, here you have 50 years old and female, but so this will be one of the answers. Like we would like to estimate 30-year-old women and 40-year-old women and 50-year-old woman. 50-year-old woman is observed here. So this is the answer, but it is very cumbersome to find 50 years old and 40 years old. Here is a 40 years old woman, but another 40 years old woman. Remember, find that this woman, excuse me, this is not a woman, this was a man, this was another man. Like, by the way, observe that these two guys have the same probability because they have the same regressors. On paper, they are 40 years old men, so they are same, identical in our data. So their predicted values are the same. So then back to the question. We have to find 30-year-old and 40-year-old and 50-year-old. Instead of looking for them, I will do it again. First, I will drop the predicted value that I generated before. I'm going to redo again, but before predicting the outcome, I'm going to edit the data. Open the data editor. By the way, so there are two options: data editor and data browser. We are going to edit using edit, and I will define 3 imaginary observations, 3 additional observations: 30-year-old, 40-year-old, 50-year-old, and they are all women. So these 3 new observations will be used to predict those women, those type of people. So 30-year-old, 40-year-old, and 50-year-old. So then let's see what we do. So this is the command for the for inputting new observations. So on do file, you may use them. And then I will recycle this command, predict again. Then you will get prediction again, and here you have the predicted outcomes. So the outcomes are the probabilities are estimated like this. So 30-year-old woman is expected to be employed with 85%, and 40-year-old 86.1%, and 50 years old 87.3%. So this is a simple way to calculate the predicted outcome at the values of regressors that you want. And after this prediction, after copying those numbers, you may delete. Right click and data, and you have to change to editor. So browsing, going to go to editor, and I just clicked this because previously I was in browse mode, but I changed it to edit mode. Then in the edit mode, you may drop this observation. So I will drop this again. Drop. And 2 variables can be dropped at the same time. Drop those observations. So then we get back to the original data again. This is a simple trick which will be very useful when you try to compute the prediction. So we are going to use this method for the probit and the logit model again later. Okay, I will continue to the logit and probit model in the next video. Bye. Thank you for watching.